Have you heard the word before? Polygon? Yeah? Okay. Does anybody know anything about it? Or can they name a polygon or something of the nature, Faith? So shape that what? Say it a lot. A shape that has more than one side. Good. What about those sides in a polygon? Are they straight? Are they curved? Are they open? Are they closed? What about them? Any idea? Okay. Off to a great start. Polygons are shapes. They have to be closed. Right, it's like a triangle is a polygon, a square is a polygon, has to be closed, and all of the sides have to be straight. So you can't have like a wiggly figure, that's not a polygon. It has to have straight sides to be a polygon. Okay, interior angles sum. The sum of the degrees in any polygon can be determined by the number of triangles that can be drawn within the polygon. Complete the table below and look for a pattern to find the sum of the degrees in any polygon. So we're going to go through. I've got a list of polygons here. I've got some pictures. We're going to, write down the number of sides, the number of triangles, and we're going to see if we can figure out a pattern as we're working our way through. Okay. So first one is a triangle, which I know you've seen before. Here's a picture of it. How many sides are in a triangle? 3, right? Here's 1, 2, 3 sides in a triangle. Good. In that triangle, how many triangles are there? It's just one triangle, right? Here's one triangle. And the sum of the interior angles, how many degrees are inside of a triangle always? What do they always add up to be? 180 degrees. Good. So in a triangle, we know it's 180 degrees. It's got 3 sides, and there's one triangle. Next polygon is a quadrilateral. Quadrilateral means how many sides? 4 sides in a quadrilateral. Good. 1, 2, 3, 4. 4 sides. Now, to find the number of triangles, you can draw something called diagonals. That's these little dotted lines here. And a diagonal just tells you it goes from one vertex to another vertex. How many triangles are in this picture? There are 2 triangles in the picture. Now, let's think about this logically for a second. Sum of the interior angles. Now, you've got 2 triangles. One triangle is 180 degrees. The other triangle is 180 degrees. In total, how many degrees is that? 360 degrees. Good. So you can determine the sum of the interior angles based on how many triangles are in the picture. All right, let's keep going, and I'm hoping you're going to start to see a pattern here. Pentagon has how many sides? 5 sides. 1, 2, 3, 4, 5. Good. Number of triangles. I go from one vertex to all of the other vertexes, or vertices, excuse me. How many triangles are in this picture? 3 triangles in the picture. Okay, again, so let's think. If this triangle is 180, this triangle is 180, and this triangle is 180, in total, how many degrees are in this pentagon? How'd you get that? How'd you get that? Yeah, you could either say I can add 180 3 times, or you can just add 180 to this number right here, right? Okay, last one, and then you're going to try to fill out the other ones on your own. Hexagon is how many sides? 6. How many triangles are in this hexagon? 4. In total, how many degrees are in that hexagon? Well, there's 4 triangles. How many degrees in total? 720. How did you get 720, Bobo? You could add 180 to this 540, or what's another way you could do it? 180 times this number right here, the number of triangles. 4 times 180, right, gave me 720. Okay, so I would like you to finish up this chart. I'll tell you this. There's no pictures here, but a heptagon has how many sides? 7. An octagon has how many sides? Nonagon is 9. Decagon is 10. I'm hoping you're noticing a pattern. Take a second, see if you can fill out those last few pieces of the chart there. Just take a second, try. See if we get the same answer. All right, so check yours with mine. You tell me if we got the same thing. For degrees, I got 900 for a heptagon, 1080 for an octagon, 1260 for a nonagon, and 1440 for a decagon. Did we get the same thing? Same numbers? Okay, now I have a question for you. What is a pattern that you notice between the sides, the triangles, and the sum of the interior angles? What's something that you notice? They all add what? Nope. Okay, so all of these from each one's going up by 1, right? Okay, 3 to 4, 1 to 2, right? Each one's going up 1. I agree. Good. What else do you notice? Let's ignore this part right now. Let's just look at number of sides and number of triangles. What about the relationship between the two? What do you notice? What?
All numbers are the same size.
Oh, okay. All right, so you're noticing this is odd, odd, even, even, odd, odd, even, even. Yeah, good. What else do you notice about those odd, odd, even, even numbers? What's the difference between these two? What do you have to do to get from 3 to 1? Minus 2. What do you have to do to get from 4 to 2? Minus 2. What do you have to do to get from 5 to 3? Minus 2. What do you have to do to get from 10 to 8? Minus 2. So, no matter what, if you take the number of sides and subtract 2, you'll get the number of triangles. So what if I gave you like a 32-sided figure? Oh my gosh. I don't even know what that would look like, but a 32-sided figure. How many triangles would be in a 32-sided figure? 30 triangles. And then what would you do with that 30 to figure out how many degrees are in it in total? You would multiply it times 180. Good. You just figured out the formula. So, sum of interior angles formula. Thank you. Okay, thank you. All right. If n represents the number of sides of a polygon, then the sum of the interior angles, S, can be found using the formula following. S equals, so the sum equals, you take the number of sides, subtract 2, right? That's what we did. We took the number of sides, we subtracted 2, and then we did what with it? Multiply it times 180. Very good. So no matter what I give you, no matter how many sides, you always take the number of sides, you subtract 2, and then you multiply times 180. And that will give you the total sum of the interior angles. Now, to find each interior angle of a polygon. So let's say I know that a quadrilateral, right, is 360 degrees. How would I figure out what each angle is equal to? What would I have to do with that 360? So if I know my total is 360, and I know that there are 4 sides total, or 4 angles in total, how would I figure out what each angle equals? What would I do with those two numbers, Faith? By 4, yeah, I'm going to divide 360, the sum of my interior angles, divided by the number of sides. That's going to give me each angle individually. So, in a regular polygon, all of the sides are exactly the same, therefore all of the angles are also exactly the same. To find the measure of each interior angle of a regular polygon, we're going to use the formula S divided by N, which just means we're going to take the sum of the total interior angles, right? That's what S stands for, the sum of the total interior angles. And we're going to divide that by the N, which stands for number of sides. And that's going to give me the measure of each interior angle. Right, so these mean the same thing right here, S divided by N. I'm just writing it in words what it says. Take the sum of the total interior angles, divide it by the number of sides, and that's going to give me each interior angle individually. So let's use those formulas now to answer a couple of questions. So we're either going to use this formula right here to find the total, or we're going to use this formula right here to find each interior angle. So let's start at the top. Number 1. Find the sum of the interior angles of a 15-gon. The sum just means I'm looking for the total sum. So how am I going to find the total sum of a 15-gon? What do I have to do? 15-sided figure, right? 15-sided figure. What do I have to do? What does my formula say to do? So it says take the number of sides, subtract 2, and multiply times 180. So how do I set up this first equation? What am I subtracting minus 2? 15. Yep, there are 15 sides. So my total sum is, I take 15 sides, right? A 15-gon has 15 sides. I subtract 2, and then I do what? Multiply times 180. Good. And that's going to give me the total sum of the interior angles. So what's 15 minus 2? 13. I'm going to do 13 times 180. And I'm going to get the total sum of the interior angles. What's 13 times 180? It's a big number. I don't know what it is. Whoa. 2003. Go. And we're talking about angles. So what should I have with this? A degree symbol. Good. That was it. That was the whole thing. Easy, right? So I take the number of sides, I subtract 2, and then I multiply times 180. All right, number 2. Find the sum of the interior angles of a 21-gon. What would I do? Someone walk me through it. It's easy. What do I have to do? 21 what? 21 minus 2 times 180. That's it. What's 21 minus 2? 19. And what is 19 times 180? 3,420. We're talking about angles, so what should I have? Degrees. That was it. Wow, easy, wasn't it? Yeah, it's not meant to be hard at all. All right, questions on those two? So far. Not bad, right? Number of sides minus 2 times by 180. Okay. Next question says, what is the measure of each? I'm going to highlight that word each there. Each interior angle of a regular pentagon. Each is important because I want to know what the individual angle is worth. Okay, now first thing I'm going to do says pentagon. How many sides are in a pentagon? 5 sides. Pentagon is 5 sides. Now, first thing I'm going to do is figure out the total degrees in a pentagon. How do I figure that out without looking at the chart? What would I have to do to find the total sum? 5 minus 2 times 180. Good. So that's 3 times 180, which gives me 540. So I know in total, a pentagon is 540 degrees. Now, how do I figure out what each individual angle is equal to? So to figure that out, I'm going to take the total interior angles and I'm going to divide it by the number of sides. That's going to give me each interior angle. So what is my sum or my total that we just figured out? 540. And I'm going to take, so this is to figure out each one. I'm going to take that 540 and do what with it? Divide it by number of sides, which is what? Oh, careful. How many sides are in a pentagon? 5. So we're going to divide it by 5. And that's going to tell me what each individual pentagon's worth. Each individual angle in the pentagon is worth. So what is 540 divided by 5? Whoa. What? Divided by 5.
Yeah, I think so. 108.
Oh, 108. Is that what you said? They said, my bad. They said 118. I apologize. My bad. 108. Okay, so if I added up 108 5 times, right? Because it's pentagon. 108, 108, 108, 108, 108. Added up 5 times, I should get 540, the total. Okay, do you think you can do number 4? Number 4 says, what is the measure of each interior angle of an 18-gon? It's the exact same process, except instead of a pentagon, it's an 18-sided figure. So I want you to do the exact same thing, and I want to see if we get the same answer. So you try number 4. All right. What did you get as your total degree measure of an 18-gon? The total, the whole thing. What'd you get? 2,880. Good. That's for the total amount. What did you get for each angle? What did you have to do? With the 18. Good. Did you get 160? Fantastic. All right. Any questions on that one? Not bad, right? Okay. So we did interior angles. Guess what we're going to do now? Exterior. Exterior means what? On the outside. Good. All right. Exterior angles sum. Sum always talks about adding things together. So that's all we're ever doing, especially with geometry, is adding things together. Exterior angles are always supplementary to their adjacent interior angle. On the polygons below, find the measure of each exterior angle along with the sum of all exterior angles. Now, that was a super fancy way of saying if you add together, excuse me, an angle and the angle right next to it, if you add together these two angles right here, you should get a straight line. And how many degrees are in a straight line? 180. Okay, so if you are given this angle right here is 79, and I want to figure out the exterior angle right over here next to the 79, how would I figure it out? What would I have to do? Subtract 79 from 180, and that's going to give me this angle right here. Good, so let's do that. We're only going to really do the work for the first one, okay? Because I know they're really small. All right, what is 180 minus 79? 101 degrees. So you just figured out your first exterior angle, 101 degrees out here. I'm going to do the same thing for the next one. I'm just going to work my way around. Here's the 40, and this angle over here, next to the 40, what do I have to do? Subtract 40 from 180. What do you get when you do that? 140 degrees. Good. So my first exterior angle was 101. My second exterior angle was 140. And now I'm going to figure out my third exterior angle. I need a color that is different. Here we go. This one's 61. How do I figure out the exterior angle right next to the 61? Subtracted from 180. It's the same thing over and over and over again, right? So it's a straight line. I'm still just trying to figure out what the other angle is. I'm going to take 180 minus 61. Well, what is 180 minus 61? 119. Okay, so now the last step is the sum of the exterior angles. What does sum mean I'm doing? Adding together. So you are going to add together all of your exterior angles. So you're going to add together 119, 101, and 140. All of your exterior angles, we're going to add them together. What do you get when you add them all together? You get what? You tell me. You can add. I believe in you. 360 degrees. Good. Okay, so in a triangle, if you add the exterior angles together, you get 360 degrees. That's a triangle. Let's try the quadrilateral. Let's see if we can see a pattern here. We're going to do the exact same thing we just did, except this time instead of with 3 numbers, you're going to do it with 4 numbers. You're going to do the same thing over and over and over again. I'm not going to write the work this time if you don't mind, just because there's like not a lot of space. But we will write in the angle measures. So I'm just going to work my way around the picture. I'm going to start over here with the 71 on the far left. What do I have to do to figure out that angle over there to the far left of the 71? Yep, 180 minus 71, and you get 109. There's my first angle. Again, just working my way around. Here's 124 and the angle right next to it. What do I have to do? $180 minus 124, I get 56. Next one, here's my 76. What do I do to get the angle right next to it? Subtract from 180, right? You're noticing it's the same thing over and over and over again. I get 104. And then my last one, here's 89. Yep, and that's 91, right? Because 91 plus 89 gives me 180. So now you've got your four numbers. What should you do with your four numbers? Add them all together because it is the sum, adding together. So if you add 109, 56, 104, and 91, what do you get? Try once more. Try again. Did I get the numbers wrong? $104. She get 360. Those are the right numbers. Well, I also heard 359. I heard 349. I heard other numbers. I heard a lot of things. You put your mask on, please. Thank you. All right. What do you notice about the triangle and the quadrilateral? They're both 360. Interesting. What do you think is going to happen with the pentagon and the hexagon? They're also going to be 360 degrees. So here's the interesting conclusion. When we talk about exterior angles of a polygon, it does not matter what shape it is. It could be a triangle, be a quadrilateral, it can be a 35-sided figure. But if you are talking about the exterior angles, it will always be 360 degrees, no matter what. So my conclusion is the sum, so sum means adding, right? The sum of exterior angles of any polygon is always 360 degrees. The sum of exterior angles of any polygon is always 360 degrees. So it does not matter the shape of the polygon. It will always be 360 degrees. There was a really cool video and I can't find it now. I'll show you a video about it later. Okay, questions there so far? All right, now we've got a couple practice problems on the exterior angles, and then we'll probably tackle the algebra problems tomorrow. So we're going to do 5 through 8 right now, and we'll tackle the backside tomorrow. All right, now before we do exterior angles problems here, we're going to write down a equation for exterior angles, okay? So here is my exterior angle equation. So you got a little bit of space down below. I'm going to do it right underneath. If you take the sum of total exterior angles. And what is that sum always going to be? 360 degrees. So if you take 360 degrees and you divide it by the number of sides in the polygon, so it's almost exactly the same as this one over here. If you take that 360 and you divide it by the number of sides, you should get each exterior angle, the degree measure for each one. So if you take 360 divided by the number of sides, you get the measure of each exterior angle. And that's going to be the formula that we use every time when we're talking about exterior angles. It's the only formula to use. So let's take a look at number 5. We're going to use this formula to answer 5 through 8. Number 5. What is the measure of each exterior angle of a regular hexagon? So we're going to take the sum of the total exterior angles, divide it by the number of sides, and that will give us the measure of each exterior angle. So how am I going to set up my equation for number 5? 360 divided by 6. Yeah, that's it. It's the whole thing. 6 sides in a hexagon, 360 degrees in total. What is 360 divided by 6? 60. Now we're talking about what? What are we talking about? An angle. So we should have a degree symbol. Good. And that was it. That was the whole problem. Easy, right? Easy, easy, easy. Number 6, what is the measure of each exterior angle of a regular 24gon? What would I have to do? 360 divided by 24. And that's going to give me the measure of each exterior angle. What is 360 degrees divided by 24? 15, and we're talking about the measure of each angle, so what should I have next to that 15? A degree symbol. Easy stuff, right? Not difficult. Okay, last 2. 7 says it's a little different. If the exterior angle of a regular polygon measures 12 degrees, how many sides does the polygon have? So this one's a little different. It's not asking me for degrees. It's asking me for how many sides does the polygon have. We're going to set it up the exact same way. We're going to use this equation. We're going to plug in everything we know. What is the sum of the total exterior angles? What is it always going to be? 360. Divided by how many sides does my polygon have? I don't know. So what do you think I'm going to put there? A question mark, an X, something, whatever you want to put. I'm going to put an X because that's what I'm trying to solve for, right? You know, we are always, you know, in math class, we're all about the X's. Okay. 360 divided by X, right, number of sides, equals each exterior angle. What does each exterior angle equal in this problem? 12 degrees. And now we've got ourselves a proportion. We've got ourselves a fraction on the left. How do I make it look like a fraction on the right? Put it over a 1. And now this should look super familiar because we've done stuff like this when we did partitioning. What should I do with those fractions now? Cross multiply. Remember this? So you're going to multiply the diagonals together. What's 360 times 1? 360 equals what's 12 times x? 12x. And then this is an algebra problem. What's the one step I have to do to get x by itself? Divide by 12. Good. I get x equals what? What? Whatever did you say? 30. Now, how should I label that 30? Is it degrees? No, it's what? Sides, because I asked you for the number of sides. So my final answer is that it's 30 sides. Is my final answer. Go like this. Okay, do you think you can do number 8? It's exactly the same. You try number 8, and let's see if we get the same answer. Use the same equation and solve for x. Make sure you label your answer. Is it degrees? Is it sides? Is it pizzas? What is it? All right, what did you get for number of sides, my dears? 9, very nice. Okay, so we're down to our last minute or so here. The last thing I would like you to do is this. We'll do the backside tomorrow, but if you have a highlighter, I'd like you to highlight or circle 3 things for me. Those 3 things are the 3 formulas that we wrote down. So the formula talking about exterior angles, I want you to highlight. I want you to highlight the interior angles formula. And then I want you to highlight the total sum of the interior angles as well. So then tomorrow when we go to do those equations on the back, you'll know to use one of those 3 equations that we highlighted. All right, so we will do the back side tomorrow. Don't lose those papers. Additionally, if you don't have a binder or a folder for this class at this point, you better get one, because I think what we're going to do is we'll start doing some binder checks in here. Okay? So if you don't have a binder or a notebook, make sure you get one. Have a lovely day. I will see you all tomorrow. Adios, adios. Bye, my dear. Have a good day. Bye. Have a good day.